Most flow meters have to sit inside the pipe. This one does not even touch the liquid. An ultrasonic flow meter measures flow using sound, and a clamp-on version simply straps onto the outside of an existing pipe. No cutting, no shutdown, nothing in the flow at all. So how can listening to sound from outside a pipe tell you how fast water is moving through it? In this video, I will explain exactly how an ultrasonic flow meter works, the two methods it uses, why clamp-on is such a big deal, where it shines and where it struggles, and how the reading gets into your PLC. Let us start with the sound. Quick note before we dig in. This is from PLC Simulator, where you can practice scaling a real flow signal free right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now, back to the meter. There are two completely different ultrasonic methods, and which one fits depends on how clean the liquid is. Start with the first, transit time. You put two transducers on the pipe, one slightly upstream of the other. The meter fires an ultrasonic pulse downstream, then fires one upstream. Here is the trick. Sound travels a little faster going with the flow than against it. So the downstream pulse arrives just a hair sooner than the upstream pulse. That tiny time difference is directly proportional to the flow velocity. Measure it, multiply by the pipe area, and you have flow. But there is a condition. The sound has to pass cleanly through the liquid. So transit time is for clean fluids, water, oils, clear process liquids. The second method is the opposite. Doppler. Where transit time needs a clean liquid, Doppler needs a dirty one. The meter sends a fixed frequency sound into the flow. That sound bounces off particles or bubbles carried along in the liquid. And because those reflectors are moving, the sound that comes back has a shifted frequency. That is the Doppler effect, the same reason a passing siren changes pitch. The size of the frequency shift is proportional to velocity. More flow, bigger shift. So Doppler is the method for slurries, wastewater, and aerated liquids. Exactly the fluids that transit time cannot see through. Now the feature everyone talks about. Clamp-on. The transducers can sit on the outside of the pipe, strapped on, with nothing touching the fluid. That is huge. It is non-invasive, no cutting into the line, no shutting the process down to install it. And because nothing sits in the flow path, there is zero pressure drop. That makes clamp-on the obvious choice for retrofits and for temporary or portable metering. Clamp it on, take a reading, move it. There are also inline versions, where the transducers are wedded and built into a spool piece. Those trade the easy install for permanent mounting and a bit more accuracy. So where does it shine, and where does it struggle? On the plus side, it is fast to fit, it has no moving parts to wear out, and clamp-on needs no process interruption. But it has real limits. It cares about fluid cleanliness. Use transit time on a dirty liquid or Doppler on a clean one, and the reading suffers. It depends on the pipe material and wall condition, because the sound has to couple through the wall, and it needs a full pipe. A half-full line, or a lot of trapped air, and the measurement falls apart. Match the method to the fluid and mount it on a good full pipe. That is most of the job. Finally, how the reading reaches your PLC. An ultrasonic meter is still just a flow meter. So like almost all of them, it outputs either a 4 to 20 milliamperes analog signal or a scaled pulse train. The PLC takes that raw signal and scales it into engineering units, liters per minute or cubic meters per hour. That scaling step is the same for every analog sensor. I have a full video on analog input and 4 to 20 milliamperes scaling, and a wider video on every flow meter type, both linked below. And you can practice the scaling free in the calculator in the description. So here's what to walk away with. An ultrasonic flow meter measures flow with sound from outside the pipe. Transit time times a pulse going with the flow versus against it for clean liquids. Doppler reads the frequency shift off particles for dirty ones. Clamp-on makes it non-invasive with no pressure drop, perfect for retrofits. And the output is just a normal 4 to 20 milliamperes or pulse signal your PLC scales. Get that, and the meter strapped to the outside of a pipe stops being magic. Now, go make it concrete. If you want to practice reading and scaling analog flow signals hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.